Welcome back. This is going to be mostly on, well, some of this is going to be still on why we're using Go as a programming language, which is an important thing to understand, but more into the how you learn a new programming language. Because one of those things I can tell you is that over time you're going to have to learn a lot of different programming languages. The reality is that the languages you use today are going to be suited for the hardware and architecture that you build now. But over time we get better at these things and architecture's changed. So part of the reason for Go is that we're moving into this multi-CPU world. And, how much multi-CPU? If you actually go and work the numbers on the stuff that Amazon Web Services is doing with the ARM processor, I would expect to see that you will have 256 CPU chips inside a box with probably 128 of these chips in a single box. You multiply that and suddenly you're looking at something that it can run a lot of threads, but threads are inefficient. But something like Go routines, you're talking running 100 million Go routines on a single box. And if you have a single individual connected to each Go routine across some sort of web connection or other connections that are out there, like WebSockets or other means by which of connecting, then basically you're talking about 100 million concurrent users running on a system at a time. And that kind of a box is not going to be cheap compared to your laptop, but you're talking about $50,000 to $100,000. And that kind of hardware is going to make a dramatic change in the world of computing. I mean, this is a revolution in computing right here. And this is all really due to the work that Amazon is doing with their processor and Apple is doing with their M1 processor. Now, there are plenty of other things about M1 that are interesting. It has hardware video encoding. It has hardware matrix multiplication and matrix solution operations. It has a neural processor. So there are other things out there that are built into this chip. And it has a variety of things that would be useful in getting you benefits in terms of performance. But the sheer number of CPUs on a low-power silicon device that we can pump lots and lots of these into a server, and because they're low power, they take up less electricity, they produce less heat, which means less air conditioning, and that means less environmental impact, but it also means if you cut the heat in half, then suddenly you can put twice as many in a box. And twice as many is a big deal. And your costs are cut in a quarter, because half of all the cost is air conditioning, so you're talking about quarter of the cost. That kind of capability in terms of servers means that you're going to see systems that are much more suited to running a language like Go, where the concurrency is built in. Now, there are 3 languages out there that are really trying to deal with this concurrency problem. The first of those is Node.js, which is very popular because front-end people understand how to write JavaScript, and it's JavaScript on the server, and consequently they already know it. I do use Node.js. In fact, Node.js is what led me to programming in Go. I was writing an application for a client, and they needed about 5,000 concurrent connections to work reliably. I built this application with the backend in Node.js because it has these asynchronous callbacks and it's supposed to be fast. Node.js is single-threaded. So it's got single thread, and that means is equivalent to 1 CPU. So it's got some advantages, but it's got this 1 CPU mine. Now, the asynchronous helps, but my performance testing before I released the application to them was that we were peaking at about 4,700 concurrent connections. And try what I could, it didn't seem like this was going to be an easy thing to get past. And I'd read about Google's Go. This was Go 1.2. We're up to 1.14 now. And I went, what the hell, let's give a trial of Go. And I didn't know the language. I just sat down and started whacking things out. and I know how to go about learning it, and I went through some steps, and my first attempt at running Go, this wasn't with any particularly good knowledge, and it was ugly code. I went over 5,000. That's what my test was for. The same application, within a week, I had broken 10,000. I did some performance tuning in between those two. But that was on low-end hardware, and I went, you know what, Node is for various reasons hard to debug, hard to maintain, it's type-free, and the lack of types doesn't do anything good for you. And this other language is easy, simple, straightforward, and much faster. So I went, you know what, we're going to forget about that. Now, since then, there's this other language called Rust that's been invented, and I do program in Rust. Why are we not using Rust if it's a better language? I think Rust is actually a better language than Go. Rust does all of its memory type checking, all of its memory allocation, and checking that you don't leak any memory at compile time. It's all figured out up front. And that is this lend-borrow concept in Rust. You know, the rest of the language, we could teach that in here in the same amount of time. It wouldn't be difficult except for this one concept. And getting good at that one concept in Rust requires that you program in it for maybe a year before you're going to get fluent at it. And I can't teach that. You just have to go and make mistakes and make mistakes. As soon as I figure out how to teach Rust, we'll probably switch over to Rust, because I think it's a better programming language. But in between these two is this nice, simple, easy to learn, small language with great documentation, tremendous performance in terms of the compiler. And I can sit down and take some piece of code that's 250,000 lines of code, compile it in Go in 3 seconds, make a change to it because I'm trying to hunt something down and fix a bug, and recompile it in under half a second and relink it and be testing. Now, you compare that kind of performance of the compiler to something like Java, and if I take 250,000 lines of Java code and compile it in Maven, I go to lunch. Literally. We're talking a half an hour. Which means my entire train of thought, my processing, my thinking about what's going on is gone every time I compile. And that means that I can't go in and say, okay, let's poke at this little thing and see if it's over here, or this little thing. No, that's a whole week-long activity. So anything in Java is much more difficult to develop because the compiler, the linker, the process is slow. And there are a bunch of languages that will compile to the Java virtual machine, like Kotlin, which I really like. There are others that I use occasionally, so I'm familiar with this, but all of them, since the JVM is designed for single CPUs, have this single CPU mentality. So I'm not too keen on those either. Also, the entire world of object-oriented, I'm probably going to irritate people when I say this, but Go uses interfaces instead of objects. Interfaces are a much better way to build and connect pieces of code together than are objects. So yeah, I understand object-oriented programming and all the motivation. I have license 40 to C++ from AT&T. There were 138 of them that were originally issued. I'm license holder number 40, so I've been there since the beginning of object-oriented stuff. But interfaces are a better solution. And that's the way Go works. So, Go. How do we learn a new program?